So we're doing exercise 5C, and in this video I'll be doing all the questions of question 4, which is asking us which of the following relations are functions and state the domain and range of each. So let's begin with A. So as you can see here, we have something that we don't normally see. It's in quite a strange form. And the first thing that we should notice is that we have this -2 here, but normally when we have it in this form, we have x and y. And we also know that my x is equivalent to all my real numbers. So what this is telling me is that for my y spot, it's only going to be -2. So I would come down to my graph and come to my -2 spot, and realize I'm only going to have values that exist at y equals -2. For x, it's going to exist for all my x values because we're told here that x is equivalent to all my real numbers. So that's going to mean I'm just going to have a straight line through y equals -2. So when it comes time to figure out what my domain is going to be all real numbers. As you can see here, my x is equivalent to all real numbers. And so too, when you look here, it's quite clear that all my x values are going to exist. In terms of my range is all my y values, and that's going to only be y equals -2. That's the only one that's going to exist. So I'm going to put fancy brackets, -2. So that's the first part of the question, figuring out the domain and range. Now we need to figure out whether or not this is a function or not. And to do that, we're going to be doing a vertical line test. So I've got that. I'm going to draw a vertical line. And remember, our vertical line test is there anywhere on this graph where I'm going to have more than one intersection spot? And as you can clearly see, I'm only ever going to have one intersection spot. So this satisfies the vertical line test. So I can say, yes, this is a function. Let's now move on to B. B is quite similar to A. Once again, it's in this funny form in which we normally have x and y, but here we have 3 and y. So that's telling me that instead of having all my x values, it's just going to be limited to the third, my x equals 3, so 1, 2, it's going to be here, 3, let me do this in blue. It's going to be here, 3, and my y is equivalent to this funny z here, and this z is telling me it's all the integers, So that means it's going to be all the whole numbers. So let me come here, and let me get rid of this for a second. It's going to be all the, that one. So just here, so only the things like 1, 2, 3, or -1, -2, -3, things like that. There are my integers. So now when it's coming time to figure out what my domain is only going to be x equals 3. And my range is all my y values, and we're actually given that. It's just going to be z, and it's going to be a fancy z. So I normally do that to tell people it's a fancy z. Now we need to figure out whether or not this is a function or not, and to do this we're going to be using our vertical line test. So I'm going to get rid of that, draw a vertical line, and I'm asking myself, is there any place on this graph where I'm going to have more than one intersection spot? And as you can clearly see here, when x equals 3, I'm going to have multiple intersection spots. I'm actually going to have infinite amount of intersection spots. So this is not a function. Let's now go on to C. C, we're given something far more familiar, y equals -x plus 3. So we know what -x looks like. -x looks like this. If I can draw a straight line, it's going to look like that. That's y equals -x, and that plus 3 is going to mean it's shifted up 3 spots. 1, 2, 3. It's going to look like that. Now let's figure out what my domain and range is. So my domain is going to be all the real numbers, and my range also is going to be all the real numbers, because let's remember that there are arrows here. So my domain will be all the real numbers, and my range will also be all the real numbers. I now need to figure out whether or not this is a function or not, and to do so I'll use my vertical line test. So is there anywhere on this graph where I could draw a vertical line and get more than one intercept? And as you can clearly see, there isn't. I'm only ever going to get one intercept. So this is going to satisfy the vertical line test. So this is a function. Next, I'm going to figure out for d, which is y equals x squared plus 5. So this is simply going to be y equals x is just a parabola here. And if it's plus 5, that means it's just going to be shifted up 5 spaces. So let's pretend that's 5 here. We don't have to draw it, I'm just drawing it so to make it a bit clearer. So that would be 5 here. Now I'm going to ask myself the question, what is my domain and range? Well, my domain is going to be all the real numbers because all my x values are going to exist because these are going out for forever. And my range is going to start, let me do this in green. Well, my range is going to start at 5 and go on to infinity. It'll start at 5 and go on to infinity. To figure out whether or not this is a function or not, I'll get a vertical line. Is there anywhere on this graph where I'm going to have more than one intersection point? There isn't. I'm only ever going to have one intersection point for this vertical line. So that means, yes, this is a function. Let's now move on to E. E is asking me to graph this, and hopefully we all recognize what this is. This is a circle. It is a circle situated at 0, 0 and has a radius of 3. So if I was to just do a quick sketch, it will look something like this. My domain is going to be, well, let me do some more. This is going to be -3. This would be 3. This would be 3. This would be -3. So my domain will be from -3 to 3. And my range will be from -3 to 3 as well. When I'm trying to figure out whether or not this is a function or not, I'll use the vertical line test. So I'll draw a straight line down here. And I'm asking, is there any place on this graph in which I'm going to have more than one intersection spot? And there certainly is. I'm going to have more than one intersection point here, 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 everywhere here. Right here, I'm going to have one intersection spot. And over here, I'll have one intersection spot. But the question is there anywhere on the graph where I'm going to have more than one? And there certainly is. So this is not a function. So we have gone through question 4 of exercise 5C, A, B, C, D, and E. Hopefully this has been helpful in answering these questions.